Good morning. Right. Firstly, look, thank you for the opportunity to come and talk this morning. But I've got an apology. I never picked up on the subtlety of the title of this conference. Who else didn't? Right, okay. So I thought I was here talking to a track community, and I wrote a presentation all about how great OLE is and how poor track is. So I'm going to have to slightly change my script as I go through, but I'm still up for those debates and challenges during the questions. So hold those questions. Sorry, I've also got a bit of a sore throat, so I'm going to have to get some water throughout, so I do apologise. So, let me just put some water in here. So, look, John Edgley this morning talked about the Chief Engineer strategy. He talked about how we have a strategy across the engineering community. We have a shared vision. In M&E, and specifically electrification and OLE, we have that aligned strategy with the wider Chief Engineer group. Our priorities are about developing our future engineering capability. It's about improving safety, both workforce safety and passenger safety. We're also looking at how we can develop the standards and frameworks that enable efficiency and productivity. And then the final key priority for us is about how we develop or enable a sustainable railway. And Peter picked up on some of the points this morning. That's about reliability, that's about weather resilience, and that's about decarbonisation when I look at it from an electrification perspective. And again, Peter touched on some of the challenges. We've got lots of work to do in those areas. We didn't have a great summer. Whilst we can look at our performance figures and say, do you know what, on those 2 days, Peter can remember the dates, 16th and 17th, do you know what, we didn't have many asset failures. We didn't have many asset failures because we didn't run many trains. We didn't have the right controls in place. There wasn't the right guidance out there. So there's lots of work that my team are currently looking at to see how we improve those frameworks, improve those designs to deliver an electrification system that meets the future demands. So, this is where it all goes wrong, by the way, because I thought it was a bunch of track engineers, so this is where it's really going to go wrong. So I try to think about, I stood here in front of some track engineers, what would you really like to know about electrification? So there's 3 key themes I'll talk about, but I'll probably go off all over the place as I change my mind looking at the room. So the first one is, why is electrification key or important to be considered when we do track renewals? The second is I want to talk through some innovations and R&D that we've been doing in electrification and how that can help drive costs down both in electrification but also across other asset renewals. And then finally, I want to quickly talk through where we are in electrical safety and how working on an electrified railway is going to change. I think there was a presentation before about headwinds and how projects aren't getting sight of those headwinds that are coming over the hill. This is the opportunity that you are going to see some of those headwinds. Because unfortunately, we have to make some improvements in electrical safety, particularly traction power electrical safety. We can't stay where we are. We have to improve our processes. So I'll give you all a view of what's coming next. So, why is it important? I've got to ask, are most people in the room track? Are most people track engineers? All the track engineers raise their hands. That's okay. I'm all right then. I'm going to carry on to my normal script then. I can stick to script. Peter, you told me it's a renewals conference. I didn't invite my electrification mates to help me. Okay, so look, I'm stood here talking to the majority of track engineers. Next year won't be the same, will it, Peter? So look, I just thought I couldn't miss the opportunity to remind you all how important it is that we consider electrification as part of track renewals. We have to work collaboratively together. And that's not just track, and that's not just OLE. That's across all assets across the railway. You know, John Edgley touched on this morning the fact that we are going into a financially constrained environment in CP7. And we have to avoid that temptation of just focusing on our assets. We can't look at just our priorities. We have to look at this as an overall system. Passengers won't thank us if we have perfect track quality, but you've got the wires down by your ankles. That's not what we need. We need to go into CP7 looking at this challenge in a different way to make best use of our money. But whilst it's going to be quite a tight financial position in CP7, the SOFA that came out Thursday, came out on Thursday, was actually a relatively positive position when you consider where the country is financially. And whilst it's not the steady state, or we're not going to be in this steady state position that we wanted to be in, I take real confidence from the fact that this is the first time in recent years that I think the Treasury has finally shown some support for the railways. You know, in this tightly constrained financial environment, 44 billion, which is equivalent to what we got in CP6, is an absolute fantastic win. But that comes with a real responsibility and duty. We have to use that money wisely. Whilst the Treasury have chose to invest 44 million in railways, think of the other services they've chosen not to invest in. So we really have that duty to make sure we maximise the value from the funds that we get. And look, to do this, I go back to the point, everything we do, we must focus on the end user. We must focus on the end user. We must look at opportunities of different interventions. And I had a discussion with Peter during the break, and I challenged, I don't like the word renewals. Renewals is just another intervention. What's the difference between renewals and maintenance? We're intervening. We're doing something. We're extending the asset life. We are just intervening with that asset to deliver an output. And so we need to look at what the right mix is. We need to look at, do we need to go to more maintenance or heavy maintenance? Do we need to look at renewals? At what point do we do that? What's the trigger? Can we do things using some more technology to deliver more efficiently? So we need to start really having those thoughts in the back of our minds. And it was great to see before Wales and Western when they were talking about their understanding of cost. It's something that frustrates me in electrification. We really need to have that forensic understanding of cost. Where is all our cost drivers? Where are all our risks? Where should we be focusing on to drive down that unit rate? And it was great to see the work that's been going on Wales and Western to understand that. And then I go back to that point. We've been entrusted with this money for CP7. Let's not waste it. If I look at year on year, I look on the renewals forecast and I look across all assets. I don't look in detail at track, but I rarely see green every year. We're dropping volumes left, right and centre. We're pushing volumes out. We're not spending the money. That can't be an acceptable position for CP7. We said this is a priority. We said we can't run a railway unless we have 44 billion. Well, let's spend it. Let's spend it wisely, but let's deliver what we said we'd deliver. And I guess going back to the point that I know you're all aware of, but I'm an electrification engineer, and I thought I'd take the opportunity to say this. Let's not forget electrification when we do track renewals. And I always get the comment that it's too expensive. It's an add-on. It was, I think, on the Wales and Western presentation, it was one of the difficult things. It's not difficult. If we engage the electrification designers at an early stage, I genuinely believe we can deliver the electrification changes, the modifications to the OLE, to the Conrail, to a minimal cost. But it's about having that right level of engagement at the right time. It's about focusing on that overall railway system. And that might mean a bit of compromise. It's about making sure we have the right competence of electrification, OLE engineer, designer working on that project. And it's not about doing a minimum. It's not about getting some height and stagger sheets and throwing some numbers in and getting some numbers out. It's about thinking what the right design solution is for that track renewal. And then it's about effective interdisciplinary checking process. I won't go into that. I know you're all aware of this. This was just my opportunity to remind you all, so you can say, you can't tell me you didn't know next time I moan about it. So, but do you know what? Actually, there is an alternative. If we say, do you know what, Phil, you're talking rubbish. We're just going to carry on doing what we do, and we're just going to focus on our asset discipline. We can do that, absolutely. You can go and get me some perfect track quality, great ride quality, but the issue is the train won't be running because the wire is going to be on the floor. We really have got to focus on what does our end customer want. That's enough me being quite provocative, and you can ask me questions about that later. Now I want to talk about some of the advances we're doing in electrification. So, over the past few years, we've spent. Do you know what? Let's start with cost of electrification. What's everyone's view of cost of? What have you heard about the cost of electrification? Absolutely. Too high, isn't it? I blame Peter. Peter was at Network at that point. No, so I don't, Peter, really. True. Our costs in CP5 were just not sustainable. So we have spent the past 3, 4, 5 years looking at those cost drivers and trying to drive down that unit rate. And we've had dozens of R&D projects ongoing to look at how we can bring that number down. And we've had projects that have looked at things like, how do we look at structures? I think somebody said again, if we went down Wales and Western and we had a nuclear attack, the only thing that would be left would be the OLE and something on the track. What was that, John? What was on the track? That thing on the track. Yeah, absolutely. We've been criticised so heavily that in electrification we have over-engineered has been the challenge. We've over-engineered what's required. It's not quite true, but we took the challenge and we've done some benchmarking of structures. We've looked at how we can design electrification structure more at a lower cost. We've done some work about pile foundations. If we look at the depths of pile foundations on Wales and Western, they were reaching 9, 10 metres at some point, when actually conventionally we're more like 3, 4 metres. So we've done some work to see how we can get back to where we were. There's been some research we've done around bridge parapets. We've done some research around maximum span lengths between structures. We've looked at our rules around grading wire. We have done some work about insulated pantograph horns, because we're one of the few countries across Europe that don't run insulated pantographs. Why? Because we said we couldn't do it. Really? When we've looked at it, we said, actually, we can. And by doing it, it delivers some efficiencies. And there's many more really groundbreaking pieces of research that we've been doing in electrification. And it's all been focused on the 2050 no diesel traction only government target. And it's all been around decarbonisation. But actually, all of this is equally applicable to renewals and other activities that we do across the railway. So I just want to touch upon one of the really key ones, which is around our approach to electrical clearances. Now, I know many of you hopefully know Richard Stainton and might have heard Richard speak at a PWI conference recently about where we are with electrical clearances and our new approach. Sometimes it's known as voltage control clearances. But I just want to give everyone a quick overview of what that project's doing, what that project's delivered, but also how it can be applied to renewals going forward. So before I get into the sort of detail, just wanted to give people a bit of an overview of electrification in terms of where our cost drivers are. When we look at the cost for new or enhancement schemes, the costs are generally split down into 3 main areas. The civils, so that's around tunnels and stations and bridges. Then we have the electrification works, which is around the foundations, the mast, the wiring, and all the knitting. And then we have other costs. So they're the three main areas. It was highlighted quite early on that actually, if we're looking at driving down that cost, the biggest area of impact is around the civils works and civils costs, and specifically around bridge reconstructions and interventions, track lowers around bridges, areas of tight clearances. We have to do some really intensive works to get wires through those tight clearance locations. So we spent many hours looking at this. We went and engaged Europe, see what the rest of the world were doing in this area, and there was nothing different. Everyone was spending millions, tens of millions, hundreds of millions on trying to get a wire through a bridge, through a little hole, trying to get a wire through. And we decided that, do you know what, let's look at this in a different way. So what we did is we said, well, why do we have to have a 270 millimetre clearance between a live piece of conductor and a bridge? And someone said, oh, it says it in an EN standard. Okay, so why does it say in the EN standard? Well, there was some testing done 30 years ago in a lab. Oh, brilliant. So what we did is we looked at this and said, well, come on, we're engineers. Why do we have to simplify this problem and specify a electrical withstand performance with a fixed mechanical distance? Yes, it's easier. You know what? It's really easy to do a design, isn't it? If you all know, to put a wire through, you need 230 millimetres. Yeah, it really is easier. It makes allocation design really easy. But actually, what we should be doing is applying our engineering expertise and saying, well, what I need to do is understand electrical withstand and look at this as an electrical problem. So it's not a fixed distance, it's an electrical performance. And by turning that thinking on its head, what we've been able to do is apply other forms of mitigations, things like surge arresters. We've been able to stress grade componentry and other mitigation measures. And we've been able to fundamentally reduce or shift our thinking and reduce the clearances required. And as you can see here, as a result of the work, we've been able to reduce down the clearances from the overhead line to the structure from 270 mil to 20 millimetres. So we know now, assuming we can put the correct mitigations in place, we know we can reduce that clearance all the way down to 20 millimetres. We also know, on the other side of the clearance, so from the wire to the train, we also know, conventionally that was 200 millimetres, and we can drive it down to 75 millimetres. I want to see who's awake. Has anyone noticed the error in the slide? Yeah, okay, you're all awake. Perfect, you're all listening to me. That's wrong. So we're able to reduce it from 200 millimetres down to 75 millimetres. And this is and to do this, we undertook lots of testing in laboratory environments. We've also installed some test sites, so on the live infrastructure, and we've also applied these principles already on Wales and Western at Cardiff Intersection Bridge, and that's now been in service for a few years with 0 trippings. And just to bring that to life, on a normal bridge, we can get trippings weekly, monthly, where that gap is bridged. We've gone down to 20 millimetres on Cardiff Intersection Bridge, probably about 3 years. God, time flies, doesn't it? Yeah, it could be about 3 years. 0 trippings, not one tripping. So we've proved that it works. And now we're seeing electrification projects across the country are now applying this theory and driving huge savings in terms of interventions around tight clearance locations, so bridges, reducing track lowers, and that's reducing the cost of these programs. That's reducing the project timescales, but also the disruption to our line-side neighbours. So it's been a fantastic win. As it says there, in CP6 alone, currently, by just going back to basic principles and applying, our engineering expertise to a problem, and looking at it a different way, in CP6 alone, this concept's saved, or will save by the end of next year, 400 million. And depending on the scale of decarbonisation, I'm hopeful it's 13,000 single track kilometres. Depending on that scale, the savings could be in excess of £1 billion. And that's just by challenging ourselves to think differently about a problem. So as I said, this concept was developed specifically for new electrification and achieving our decarbonisation targets. But actually, the approach is equally applicable to when we do any work on the railway, any tight clearance location, any renewals, any maintenance activity. We're able to apply the same principles and achieve a lower cost intervention. And just to try and bring this to life, there's no pointer, is there? Okay. What you can see here on the right hand side is on the left hand, 1, 2, 3, 4, first 4 bars. That's conventionally the soffit heights we're used to from track, high level to the soffit. They're the heights that we're used to design to in terms of minimum across the infrastructure. The second from right is where we got to in CP5. Not where we needed to be. And the right-hand side is where we now are at. So it visually shows you the fact that actually we're now able to really drive down that minimum soffit height, or minimum height of the structure. And as I say, that just brings, or it changes our view on what trigger points are for different interventions. That's across all assets. There is opportunity here for everybody. The only one caveat I must say, because Richard Staten told me I had to say it when I'm stood up here, this only works when you consider it as a system approach. So we don't get an electrification engineer going, you know what, I can drop my bridge all the way down to, what's the height there, 4240, or we don't get a civil engineer doing the same thing, because the key to this is the railway system, because everybody needs to sign up to the risk and tolerances and additional or different maintenance regime that might come with it. Because it's about balancing those tolerances, and that's how you achieve those heights. So, I think I'm moving on to our last area, and I think I'm doing okay for 5 minutes. Excellent. Not doing brilliantly for time, but I can make it work. Right, so the next area is electrical safety. And look, I'm really passionate about electrical safety. This, in my role, takes up the majority of my thinking time at the moment. Look, I'm a strong believer that we should never have an accident on the railway. Never. We should never have an accident on the railway. And I'm also a strong believer that we should never have an accident from someone coming into contact with live equipment. I believe, it's a personal view, not shared by everyone across Network Rail, but I can say it because I'm stood here. I believe the issue is we need to eliminate the belief that accidents just happen. I feel sometimes we sit there and go, accidents just happen, don't they? It's an accident. We need to drive that belief out of the industry. And look, just to bring this to life, there's many examples over recent years where in electrification terms we've got this wrong. I think John showed a picture of Goddington. I think he illustrated the point quite well. How many of us would allow us to have a hole in the roof in our houses above our fuse board? Well, how many of us will have holes in the roof actually? But anyway, that's a different point. It's absolute basic stuff. We had Kensal Green, where someone coming into contact with live equipment, avoidable. We had Wolverton, someone coming into contact with live equipment, avoidable. We've got to drive out that belief if we are going to achieve the zero harm railway that I think we all want. We've got to drive out those behaviours. So, what have we been doing? I just want to share some successes before I move on to where we're going next. First one, reminder of live equipment. Who's heard of it? That's okay, that's not enough, but that's good. So reminder of live equipment. These are new blue flashing lights. Okay, they're blue flashing lights. And we put them up to the extremity of isolation. This is to remind you, do not go past it. It is live and dangerous to the side. Too many times are people straying outside their isolation limits and come into contact with live equipment. So this was a initiative that was launched last year, and it was rolled out nationally in February this year. A fantastic success. I'm really pleased of how the industry engaged with this, and there hasn't been one site inspection from ourselves or from the ORR where these haven't been used. And we've also been checking paperwork, so it's a fantastic level of deployment, so we're really grateful. The second is around test before touch. You'll see there a new test before touch standard has been or was published in September this year. Compliance date of 4th of January this year. Please, 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 please get through your briefings. As of the 4th of January, if you've not had your briefings, you are not competent to work. And we were going to take a really hard line around this. When we look at test before touch has been in force since 2015. And I guess the best way to describe its application is inconsistent. Okay? The standard has been published. It's going to give us a consistent application of that rule. Please apply it. Every single incident over the past 10 years where somebody's come in contact with live would have been prevented if someone had put a tester on. Every single one. There's absolutely no excuse not to do it. So please, 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 do your briefings, follow the standard. We've also got some work going around technology, negative short-circuit devices on the DC network. This is all about how we deliver a safer technology, but also how do we deliver faster isolations at the same time. And what we've got on the left-hand side, you can see a conventional DC isolation. You can see lots of straps. You can see lots of driving. You can see lots of resource. Versus on the right-hand side, negative short-circuit device. It's a controlled by a panel. It's a switch on the ground. Provides the same functionality of a strap. Delivers workforce safety improvements, electrical safety improvements, all of those great things. Also, we're looking at how we improve processes. We're also looking at how we improve technology, but also we have a cultural piece. And that goes back to the point I made about test before touch. It's been enforced for 7 years, but we're just not doing it. So this is a cultural piece. We've got 2 campaigns which have been launched. We have the Choose to Challenge campaign. That's about reminding people they have a voice. If something doesn't look right, please speak up. With some great videos that have been released where people are talking through their experiences where they wished they'd have said something. We have electrical safety step up. That will be launched across the industry in January. We've been piloting it, great feedback, and that step up will be launched to all electrical roles shortly. Really quickly, some more process changes coming. I'll just pick up on 3 because it really affects everyone in the room, and we talk about headwinds. The first fundamental change you're going to see coming next year is around electrical risk assessments, hierarchy, electrical safe systems of work. Please do not think this is insignificant. That means every piece of work, everybody plans on the railway, will be planned differently. And that means everybody is going to have to do really robust electrical risk assessments because we are not doing them. So that's going to be a real fundamental change that comes next year. We've then got optimised earthing. Optimised earthing currently being trialled on Wales and Western. It is actually a fantastic safety improvement, but also allows us some productivity benefits as well. That's about how we can move to local worksite earths, personal earths. Put your earth on the wire, you know you are safe, it is earthed. So it delivers a fantastic safety benefit. It also allows us to reduce the number of earths we install. So instead of putting earths every 400 metres, quarter of a mile, up and down the track on your isolation, you can just have your earth at the extremity of your isolation and a personal earth to keep you safe. It's a fantastic improvement. The last one, another really key one that will affect people, electrical clearances and safe working distances. We are looking at aligning our safe working distances to other European railways and it's about getting people further away from live equipment. Today, we allow people to work up to 600 millimetres of live equipment. It's a 600 millimetres from live equipment that can kill you. We're now looking at saying, come on, what is it going to take to get us further away from that? And we're looking to align to European practice of using what they call a vicinity zone. Essentially, it's about getting people further away from live equipment. And just going back to the point, that does mean more equipment will need to be isolated. So it does come with that headwind. But what we're looking to do, all those headwinds, we want electrical safety improvements to be sustainable. And the only way we're going to make them sustainable is also making them affordable. So to try and mitigate some of those headwinds, we're also looking at introducing some technology. So we have remote securing. So that's about how we can, instead of sending people out to apply padlocks, how we can do that with our remote means and deliver some time-saving isolations. We've got some earthing pantographs. That's about, there's a trial in Wales and Western at the moment, seeing how we can, for a moving work site, can we use earthing pantographs on vehicles. It's common practice across Europe and delivers some safety and efficiency benefits. Negative short-circuit devices I've already touched on. And then we have a work stream looking at next-generation technology. That's all about how can we move to more electronic permitting and planning processes? How can we move to more e-workflow? How can we look at fixed intelligent roll devices? So instead of sending people to put them up, can we have them that they appear from wherever? I don't know. So we're looking at lots of ways that we can deliver some savings, because we know the process changes are going to deliver headwinds to the industry. The graph there just tries to illustrate it, but I know I'm well over on time. Look, thank you very much. Thank you for listening, and I hope there's something that sparked your interest. So thank you.